Weaver questions and answers for basic electronics.
Question 1. Can you explain the concept of Ohm's law?
Answer: Ohm's law states that the current I through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance ERE between them. Mathematically, it's represented as IVESV.
Question 2. What is a diode and how does it work?
Answer: a diode is a two-terminal semiconductor device that allows current to flow in one direction while blocking it in the reverse direction. It operates based on the principle of the p-n junction. For example, a common application is rectification in power supplies.
Question 3. Explain the operation of a common emitter transistor amplifier.
Answer: in a common emitter transistor amplifier, the transistor is connected such that the input signal is applied to the base emitter junction and the amplified output is taken from the collector emitter junction. This configuration provides both voltage and current gain and is commonly used in amplification.
Question 4. What is the purpose of a flip-flop in digital electronics?
Answer: a flip-flop is a bistable multi-vibrator used to store binary information. It can be used to create sequential logic circuits, such as memory elements or digital counters. For instance, a D flip-flop stores one bit of data and can be used to build a simple binary counter.
Question 5. How does a basic low-pass filter work? And where is it commonly used?
Answer: a low-pass filter allows low-frequency signals to pass through while attenuating higher frequencies. It consists of passive components like resistors and capacitors. An example is a simple RC filter used to remove high-frequency noise from audio signals.
Question 6. What is the purpose of an operational amplifier, op-amp, in electronic circuits?
Answer: operational amplifiers are versatile electronic devices used to amplify, filter, and perform various mathematical operations on signals. They have high gain and are commonly employed in signal conditioning, instrumentation amplifiers, and active filters.
Question 7. Describe the differences between NP and NPN transistors.
Answer: NPN and PNP transistors are both bipolar junction transistors BJS. The primary difference lies in the arrangement of the semiconductor materials. In NPN transistors, the middle layer is p-type, while in PNP transistors, it's n-type. These differences affect the transistor's behavior and biasing requirements.
Question 8. What is the significance of a Schmitt trigger in digital circuits?
Answer: a Schmitt trigger is a comparator circuit with hysteresis. It is used to convert a noisy or slowly varying input signal into a clean digital output. For example, it can be used in debouncing switches or generating square waveforms from sine waves.
Question 9. Explain the purpose of a voltage regulator and provide an example of its application.
Answer: a voltage regulator is used to maintain a constant output voltage regardless of variations in input voltage or load conditions. An example is the LM7805 voltage regulator, which outputs a stable 5-wave supply voltage. It's commonly used to power digital IC in various electronic devices.
Question 10. What is the difference between an analog and a digital signal? And can you give an example of each?
Answer: an analog signal is continuous and varies smoothly over time, while a digital signal consists of discrete values. An example of an analog signal is the sound wave from a microphone, and an example of a digital signal is binary code representing text in a computer.
Question 11. What is the function of a capacitor in an electronic circuit? And how does it store energy? Question 12. Define the term frequency in the context of electronic signals and provide an example of a high-frequency application.
Answer: frequency refers to the number of cycles oscillations per unit of time, typically measured in hertz size. A high-frequency application is radio broadcasting, where frequencies in the HMEHM Waltz cage in BEP HAUs are used to transmit